Hey YouTube, we're back at it. We are going to continue creating the backtesting project. And yeah, let's get right into it. Uh, Probably don't want to see my OBS studio, do you? Okay. All right. We'll have the chat up here. Okay. So we're back at the backtest. We are going to. So the backtest yesterday was taking too long. So I've kind of started. What's up, Sasha? Sasha's in the house. Okay, we got our top fan here. Sasha learning the trade. All right. We're back to making the project. I need to commentate now, Sasha, so this is how you do it. We're gonna restart this to update. And yeah, let's keep it going. All right. We're gonna grab some context here. And we will pull up the AI. All right, config syntax, okay. Do not carry. All right. Let's just full code. Let me think, how can we make this project like taking certain, well, okay. So the back test is kind of all over the place right now. I want to, I really want to move to feather. So, okay, I want to refactor to run back tests with feather and maybe pre-process the Parquet files more so that the back tests are more optimized and run quicker. We'll give him system spec here. Okay. Get some light in here. Great plan. You can speed up both processing and the backtest loop by switching to on-disk formats to avoid faster I/O where it helps. Feather, IPC. Okay. Okay. We're going to get this going. So we're going to convert the backtest from the Parquet to Feather, which now I'm kind of curious on what other formats like Feather are there for back testing, frequency data, trading. Let's just get a quick overview of what options we have. I think we're going to get this going. See if my phone is on. All right. What do we got here? For back testing high frequency trading algorithms, you need formats that are fast, efficient with storage, and good at handling time series data. While Feather is excellent for quick temporary writes and language interoperability, other formats often provide better compression and features. So we're already at Parquet, Apache Parquet, hierarchical data frame format. Huh. HDF5. It's like a self-contained file system. Czar. Huh. You know what? I think we're just going to stick to Parquet because that was like the #1 there. Feel like all of this is going to be overly complicating things. Okay. We will just run Python backtest and get the error here. Okay, I see. So actually it did see this error before I even I want a new file. Help fix code output. I want a new file called run.py that runs just a quarter of the data to iterate and quickly run back tests instead of going through the whole data. So we're gonna make another file that runs just like half the data or a quarter of the data. I'll be right back to get more water. Okay. We're back. We're getting this going here. Put my mic back on here. All right. So config had an issue. And then we're going to make run.py to just do real quick short bursts of data. Shoot, it's too much data to copy paste, but audit log is not working, but okay, we're running backtest right now, so this is a fully custom backtest engine. Okay. We're using polars as the main thing here. We'll get some, okay. All right, we're gonna keep optimizing. That was pretty quick though. And it looks like we took 24 trades. Um, the mid price is back. And yeah. So yeah, we're gonna get this really tuned really well, and then we're gonna just iterate on the coding aspect of this. Yeah, that's good. No gaps, outage block, looking good. I think we're gonna get some decent backtest run today, and figure out if this core algorithm is going to be useful. It seems as though we're trading a bunch, and the fees are going to eat up a lot of that profit. We could remove fees and see if it's just profitable without fees, but it's probably not the best idea to do that. Okay. See what we're changing here. Okay, we're going to change back to us. We're going to config here. All right, we're going to do append rows CSV helper using Python to support. All right. We're just doing some optimizations, and yeah, that's all we're doing here. So we'll optimize backtest, so that's finished. And yeah. And then we'll get run to be use lazy scan parquet. Okay. Slicing to avoid loading full files into memory. Cool. Yeah, so we'll run it back here once this is finished. The last time we ran it, we got, let's just kind of review. There's no audit log here. So, okay. Yeah, see, it spit out an error there. Let's see. So we're definitely getting some sort of indicator action. Like Bollinger Band, I assume we're doing that. Um, all right. Let's run another one. All right. Got some data here. Just slam it with the data, see what's going on. Okay, audit appended dictionary. Okay, thank you for the logs. Normalize audit rows to a fixed schema before writing. We'll define a single order field list and fill. Okay. We're gonna do some normalization. Normalize so that we can get a nice audit log. Apparently that was giving a bunch of zeros there, so we need as much data as we can from these tests. So this sounds good to me. Get the audit going here. Raw I/O speed, quick data dumps, temporary storage, sharing between Python. Yeah, honestly, Parquet is probably the best one. Yeah. Although it's good to know about these other ones. I thought Feather might beat Parquet on speed, but if we're doing short bursts right now, just to hash out some of the bugs in this software, and then we'll go do a full run just to double check because we want to see if it's going to be accurate before we run a full test. All right. We got Vectus. Okay. I believe this is going to be the run file. Okay. That is the run file. So we'll clear this out, run another test. Clear the Pi cache. We'll hide the data. And probably crunch that a little bit, make this. Yeah, we can do that. All right. Code is finished. And we will do run. Run it up. Python, run. Now, let's just get top down there. We'll go from, well, I can probably get the whole thing. No, we definitely can't get the whole thing. Let us see what's going on. Lost money. How many trades did we take? We took 24 trades again, so it's very consistent. So let's see what Horizon has to say. Looks good. A quick runner executed, the curious slice, the system regenerated, trades executed, and the Odyssey has written successfully. Yes, it did. Okay. Audit this. Okay. So it's okay. Oh, the web search kind of made it. All right, let's think here. Success. Odyssey is not consistent headers and matches a normalized schema. Okay. If you want even cleaner CSV for downstream tools, how do I run? Around all right. All right, we're gonna get run to do a full test. We're gonna do a full back test. This is actually pretty exciting. This is taking a lot of effort to get the data ready. We pre-processed it, so this should be fairly quick, hopefully, maybe like 5 minutes. I'm guessing, but it could be a lot longer. But we're going to see. So we're going to backtest my strategy over 2 or 3 months of high frequency data. Let's go. All right. And we're doing it. We're going to see how good the strategy is working. Let's see. Can everyone? Yeah. It's going. So that's awesome. Now, we don't know how long this is going to take. I'm pretty sure it's going to take a couple minutes. Let's check the stats of my computer. Not fully maxed out, which is great. Now, what we're going to do is a little bit more advanced. We're going to just assume that it wasn't that great. Like the strategy is okay. And we're going to have AI optimize the strategy. Okay. And we're going to do that. All right. So review the alpha and edge. Run a sim data through your head. Talk through how the math triggers orders and refine the strategy. Ensure profitability in all regimes. Think of novel math to enhance the algorithm. This is the most advanced quant abilities we got here. All right, below is a focused review of the alpha execution logic and risk controls with concrete changes you can implement in the current code base. I'll run the sim in my head using your data flow and math, and then purpose refinements to improve the profitability across regimes. Okay. High level read. Where the edge leaks today. SCOM calibration drift. K BPPS per Z. Assumed constant 18 bips per. Okay, but realizable. Okay, let's keep going here. Concrete improvements. Conditional calibration and entry thresholds. That sounds good to me. Dynamic cost model. Okay, volume adjusted slippage. Replace constant slip BPS with function of spread ticks and volatility proxy. Okay, so we can make it a little bit more accurate. We're kind of just throwing like we automatically slip so much when we trade, so it will give us a more realistic output, but we can make it a little bit normalized MicroPython OFI. Uh-oh. It looks like we're done. Just kidding. Not even sure what. So maybe that was just a pre-processing. Yeah, okay. Not so bad. We will give it some of this. Ooh. We'll give it just some of the audit log. Okay, let's just review the summary of what we got. We had 74 cooldowns. We had 21 Widespreads. All right. No signal was a lot. We had 206 trades. Yeah. All right, we will continue iterating. This is how we do it. Okay. We're gonna just enhance the edge or the strategy here. You can see the cooldowns in the data. So I'm highly skeptical. Well, okay, it was going. So it had a cooldown there. Oh, see, during the cooldown, then it probably needs some sort of buffer before. Okay, let's see. Feed BPS reason mid spreads. Okay. And then we got a bunch of zeros here for some reason. Something happened in the data. It looked fine going here, but 5. Okay. We didn't lose that much money for only taking 200 trades. And this is over 2 months. Let's grab this. Look, are we grabbing the... No. This doesn't get CSV. Only gets the parquet. All right, core. What's modified? Huh. I think it got cut off there. Um, okay. Let's keep it running here. Now I'm concerned it's going off of this data that we filtered and then we added indicators. So I might just convert all of these to CSVs and just kind of like peek into what's going on in that data, just because that's much easier for me to see it. And we'll make a new file called CSV.py. I will make a new folder, CSV, and we will run it back. So here's a drop-in replacement. Assumes you updated core PY and preprocess per earlier guidance so that indicators includes regime. No, we did not do that. We definitely did not do that. I'm going to delete the, that's the problem. We need to make a new folder. Data, I don't know what to call this. Filtered? I'm just call it filter. Okay. All right, we got the full backtest file. We're gonna grab the context here. Just gonna remove the audit log. We don't need that. And we will grab the raw data. Let's fully redo the pre-processing of the data. Let's have the new pre-process data get output into the filter folder. So the raw data can remain full code files full. All right. We're doing this at a high level. We can do this at the highest level here. Great, let's fully redo the pre-processing so that the derived artifacts are written into a dedicated filter folder while the raw data remains unchanged. Okay, so that means okay, L1 book is not what we need here. Filtered is not what we need in here. Not sorted either. Indicators also. So I'm pretty sure that was my raw data. Let me just double check here. The silver. Yeah. If this will, I could run raw again and just see. Python raw.py. Ah, shoot. Well, great. We'll figure it out. If I need to go back to this, that's totally fine. Totally fine. Okay. We'll see what's going on here. Config is going to get tuned up. All right. We're going to get a new core. I don't know why we have to. I'll put the new core, but we're going to do that. Oh, I definitely cannot name that CSV. We'll just call it look. So we're going to output the filter data into the filter folder. I'm going to have this. Oh yeah, CSV cannot be named CSV, but it can be named look. Okay. So we'll run context grabber one more time. we charged up on the phone here? We are. We are charged up. It's great. I'm gonna add the little fuzzy thing. Okay, actually, this. Okay, we got full. So pre-processed data. So we have core here. I don't know about that. I don't know about that core. It really condensed all of that. All right, we'll run it. We'll run it with the new one. It's condensing. All the same math though. That's all that matters. Always getting out of hand. Let me take care of this bug here. Okay. Huh. Okay. Before we run the filter and all of that stuff, we're going to reset. We're just gonna have it review one more time. One more time here. View code. I want the best. We're gonna optimize again. We're gonna run it through. But just because like I don't want to waste my time pre-processing a strategy that will end up changing. So I don't. So the L1 is kind of bothering me. I need to. Okay. Can unlock much stronger multi-horizon OFI family below our drop-in designs. 40 slower, the width. Okay, we're going to get a bunch of new indicators here. We're going to pre-process the data again, and then we're going to run a new decision engine, I guess. So you know I hit it really hard with something that has to think about. It's going so slow. All right. Let's just get a deeper understanding of what it tried to give me before. Um, okay. We will review this strategy and then we'll discuss how to make it better. Okay. So I think it's trying to, with Q absorption, classical open extended with dual memory of Q absorption, Q replenishment. Okay. Yeah, so if we have data that extends beyond the L1, we have 20 levels of data, so we might as well utilize all of that order book data to come up with something a little more advanced. So, um, yeah, exactly. Yeah, the OFI needs to be reading the order book. Right, below is a compact blueprint of a novel path dependent microstructure math designed to resist decay. There we go. Um, okay, so we're gonna reuse some of the core ideas, but we're gonna expand it to uh, just more of the order book. Okay. So why the stack resist decay? Path dependence in memory, AR memory, and curvature trends embed low or how liquidity changes persist beyond transient flow. Structure, not just volume, entropy and convex envelope detect shape, cliff properties, not just how much size. Elasticity coupling features scale by spread elasticity. They naturally downweight noise in poor conditions and focus on high quality regimes. Cross-scale shelf consistency enforces agreement between fast and slow components without rigidly forcing momentum or mean reversion. Regime local normalizations. Each feature is standardized within its regime distribution, avoiding dilution during transitions. Okay, if you want, I can produce the concrete polar function. I have a double check again. Double check your work here. So that, yeah, never take the first answer that's given. Okay. So it's just finding a ton of flaws and it's okay. Input hydrogen cause okay, from fixed out of the previous. Do I have a fix? Huh. Where did it come up with that? Oh, it must have. I don't know. No leakage, strict causality test, shift test, but okay. So given your data set, given stats, book levels, billions of rows, yeah, it's a lot of rows. Density to estimate queue memories and entropy reliably. Fix audit is found at 200. Okay. With the guardrails, if you want, I can supply a small pillars module. Let's see, is there... Just think like we can do anything with this data. Yes, okay. Before designing new math, you can extract and validate the existing alpha latent in your data. Okay. Forward returns at multiple horizons. Okay. Hmm. All right, we're gonna run just some baseline math just to ensure we're not going crazy with this data. What did... All right. So I think it's pulling those fix and tune from... Hold on. Where is it getting these files from? What? Has this been working? Yeah, look.py. I don't see any fix and tune. All right. We're just gonna run. No. Yeah, I deleted all of the data. Okay. Okay. We'll see how long this takes. New file, alpha.py. There's a lot of back and forth when you're designing these things because I'm learning, everyone's learning here because look, is there any sort of tutorials online how to backtest high frequency data with this specific data set? No. So this is going to give us baselines for uh, just like simple math, like known OFI, known whatever it was going to run, but I forgot what it was going to run. It's definitely just focusing on OFI really and building out 1 second level edge. Python alpha.py. Okay. So running into that issue where it's not, doesn't know exactly the new polars API stuff. But Grok can come in and help with that. All right. We're gonna run alpha. We're going to get Grok in here because alpha is not working. We're gonna go quick answer. So want some quick thoughts here. We have L2 data. All right, we're gonna just do it like on a quarter of the data, not the full set, because this is just kind of a baseline. And I'm pretty sure the data started. When did our data start? Somewhere in May. So it should be fine to just run like, even if we do it for one daily candle. So we'll see. We'll see how this works out. Alpha report. Let's go. It's probably gonna crash the computer. Okay, we had spike. spiking again. Okay. Quick answer. Okay. We will give this to Horizon when it's done. Okay. So we're going to run just an alpha report to see what is going on in the data on a small subset of the data, because we're not running a full one right now just for this. We're trying to iterate, make novel math. Okay. Okay. Run it on a subset of the data. And then whether simple, well-known microstructure and your data set are strong enough to trade. This might actually be a waste of our time here, but let's see. Is this exploitable drift after order flow imbalance? Oh, guys. Yeah, I'm a little bit in general. Yes, OFI works in literature across many market venues. Decades of microstructure research and plenty of shop lore on the net balances. Okay. Getting some errors. Huh. So it's questioning itself on the yeah. So OFI is definitely a known edge, and it's just looking at the the most fine-grained details on supply and demand. And since it's Bitcoin, really that's all that kind of is driving the price action, besides like news events and other people's trading bots that are driving the action. But if you can read the fine-grained detail, in theory, you can extract some sort of edge from it. Let's get the alpha report here going. Wow, I'm gonna clear that Python alpha. Okay. Hmm. Regimes. Okay. Yeah, we've done this sort of. Like we've run so many tests on the data. Maybe just forgot. Okay. Yeah. It's okay. Can we align and trust it? Which is you inferred tick 1.0 from the book. Confirm fills, obey that tick and minimum trade share. Side semantic and fills, duplicates. Like I'm pretty sure we covered that the data is good. That sort of um yeah. This throws me off where you have to like kind of skew each one like 100 to 300 milliseconds. Mm, okay. Maker taker fees and intended. Hold on. Yeah. So, okay. Now we're just kind of focusing on like what alpha to go with or what edge to extract here. We're gonna start simple and like work our way up to more esoteric and novel aspects. Because at the end of the day, it's like if something simple works, then we'll just kind of go off that. But if not, then we'll just go full crazy math, maybe some AI. Um, hmm. Yeah. All right. Let's get this alpha report going. Alpha report needs to work. Mm-mm. Yeah, exactly. I don't know why we're only focusing on like a couple levels of data. We need L20 leveled out. Okay. All right, we'll focus on just the couple first levels of order book data. Um, Running hot and 100% CPU. It's definitely affecting performance. Um, okay. Whoops. We're gonna give it the data here. We're gonna review the data. The alpha is failing big time. We're gonna need Grok to just come in and save the day. Okay. We'll run it back. Your data are consistent, the pipeline is performant, and the tuning results make sense. Use 200 to 300 tolerance. Apply negative 72 millisecond audit offset for diagnostic. Incorporate correlated outage mask into the rerun fix with a total of 200 to confirm coverage. Come at it from a different angle. Hear that loaded. Okay, the system mouse. Okay, we'll just use the math. Okay. So we almost have everything. What still needs are the deprived preprocessed artifacts and a few optional inputs. So, yeah. So, huh. We disconnected And we're back. Interesting. Was that because of this? I thought I ran alpha report, but I don't think it worked. It's weird. All right. Okay. Um, but we're waiting for this alpha report here. Oh, okay. So run this. See if we can't just somehow use the data and extract some sort of profitable ability. I'm going to eat a little bit of food while we run this. Okay. What is going on with the alpha report here? So we're running. Oh, yeah. Hmm. See if Horizon can't figure it out. Not too sure if it was the if it had the most current code. Yeah. Okay, well. Let's see if this works first. No, I ran out of. What happened here? Run this. A little bit confused on what the difference is. Okay. Mm. Okay. Okay, I see what's going on here. No. Okay. So what we're doing is a little bit different. In order to speed up the back test, we need to pre-compute indicators. What we're going to do now is we're going to make sure that those indicators are giving us good data. So it's constantly, we're changing data, making sure it's good data. We'll be able to tell if like there's a good edge with this data or not before backtesting. So that's where we're at. It's so weird. I'm not able to look at the code because that's kind of a bug. Yeah, we don't want to run the whole thing just yet. Okay. Okay. We'll get this one day. We ran a couple back tests today, but ultimately it's back to the drawing board. It's just too formidable, this billion row data file. It's too aggressive and it was too large for data set. All right. Just run the alpha report, see if it will work. All right, we'll just change a little bit of what the alpha report will do. Because when I run this, I want to know that it's working, and then also I don't want to have like a giant CSV. Rather, just have all that knowledge condensed into a nice little summary. We'll get that. We'll get that chance. I might need to do like yeah. I don't know, well, I guess I could look it up real quick, so another error, but we'll get the script running. Then maybe I'll do it on the whole data file without taking it. Okay. So what we're going to end up doing is we're doing this alpha report because it's going to actually like it's going to extract the indicators and then look at the indicators intent. And from that we'll be able to see if any of our indicators are extracting any sort of edge or alpha before we just start randomly throwing backtests at this data. So it's actually a little bit smarter way to do this. So we'll pre-compute our indicators and then we'll just do that alpha report on it before we run a sophisticated decision engine and other things like that. So let's just make sure this is running on a small subset of the code or of the data. And then, yep, let's not crash the computer though. We're still streaming, so nothing crashed. Um, so okay. All right, I'm gonna quickly. Okay. So it worked. Let's close out of that. Where was the data? Hmm. Yeah. It did not print anything that we wanted, so. Load it up. Hmm. Waiting for us to load. Okay, looks like GPT-5 will be released tomorrow, probably. That's gonna be sick. which is what we're using essentially right now. But maybe they'll release a ultra version or a better one. We'll see. Mm. It's for sure. OpenAI tweeted. Let's see. Um, yeah, look at that. Live stream, but with the 5 for the S. All right, well, that is not working out here. Come on, GPT-5. Oh, okay. That's not useful. Well, GPT-5 tomorrow. Not useful. Use this command here to just run it fast. quickly find all the errors. Okay. So if you're tuning in, we're just trying to run this alpha report. And essentially it's going to compute indicators on the high frequency data. And it will see if they're valid, essentially. It's going to just see the intent from the numbers, and it will essentially extract the alpha before we even backtest. That's like the core of the idea. Novel risk. Huh. Oh, is it working? It's not. It's supposed to be fast. It's working. So close. Let's see if we can't get. Well, we'll wait for this. What did I think is wrong? Stratified deciles. Try to group. Put the evaluation frame past decile report. Complete those columns. Oh, shoot. Basically, it missed two things. Okay. Get this alpha report working. Then we can go back. So most of the coding I've been doing is just double checking the data. It really has been. Now, trying to think here. OFI simple, OFI 1 second, OFI EMA 250, OFI. We're testing all of the OFI. MP delta, L1 balance, regression ratio, elasticity. Okay, EPIN. We got all of the features here. These are decent, but we could probably make it a little bit better. Let's go Python fast. If this doesn't work, we're going to move to Grok and see if that. All right. See what Grok has to say. All right, I'm back. Let's get the alpha going. Let's get the alpha up and running. Okay. This should have done it. And we will make sure. No. Didn't work. Let's get an iterative process here. Honestly, maybe QuantCoder can figure it out. There we go. Did it figure out? Okay. It's just trying to read different data buckets. All what's failing really is the summary. So 100% prefer the response that gives me the full code. All right, well, I didn't give it that proper context there. I prefer the right side. We'll get the alpha report running. Okay. This is gonna basically test all of my indicators before we run the back test. We want to make sure the indicators are producing some sort of edge that, you know, if we look ahead, we can see that the indicators are making edge. So this will be kind of cheating, but that's the whole reason why we have data, so that you can do. So we're getting decent alpha over there. Getting decent alpha. What did it do? Shit. You know what? Mess it up. Shit. You ready? We'll get Quinn 3 in here. We'll see. We'll see how Quinn 3 does. Whew. And then if we're getting some decent alpha from this, honestly, we'll just run it back with some different indicators. I think right now we're trying to test, where is it? Here we go. These are some of the indicators we're testing. You know what? Let's get a read on. Okay. Man, the alpha script is getting massive. Yep. Okay. The methodology we've implemented is excellent and highly professional. The script provides a sophisticated framework for testing the predictive power of various financial microstructure indicators. You are correctly testing for a monotonic relationship between a feature's value and future returns, which is the definition of a viable alpha signal. So, this alpha report is by far going to give us a great idea of what direction to head in. So, this can be just like an indicator test bed. It'll run the indicators, look ahead, see if it's giving any sort of predictive power, and then we can build the decision engine off of this. So, the code is well structured, positive, cathartic. Okay. Inclusion of script is a powerful tool. It doesn't contain alpha itself, but is highly effective factory for discovering and validating it. Perfect. Instead of just running back tests and then running it again, this is the way you should be testing. It's thinking beyond just the back test here. We wanna see how these indicators perform. Hopefully it doesn't crash. Let's see. All of our files will be imported there. I will actually get I'll start dragging some of the CSVs into maybe like ChatGPT. Grok didn't work there. Look at that. Here we go. Oh, it's too much data. Alpha summary. All right. Awesome. This is exactly what we want to see. We're going to, now my question is, can we actually, oh no, it's from Z. Can I, okay. Is that too big of a file? Okay, it worked. We'll give it the code base. Yes. Okay. So let's see if we can't read this. So mean, standard deviation, total aggregate mean. Okay, so OFI EMA 1000, an L1 imbalance, a measure of the imbalance. Huh. Okay. So we got some direction here. Now we can run it more, but honestly, this should be enough to iterate on, at least. Of course, the alpha signals generated by your script are potent because they are grounded in fundamental principles of market microstructure. They don't just find spurious correlations, they systematically quantify the information advantages and inventory pressures that drive short-term price movements. Here's a PhD level breakdown of why this alpha likely outperforms simpler strategies. OFI. Okay, the evidence. Negative relationship between OFI EMA 1000 and forward returns. The top decile highest buying imbalance has a forward 10,000 millisecond return, of negative 0.35 bips, while the bottom decile highest selling imbalance has returned point. This indicates a predictable reversion. Market makers facing this toxic one-sided flow widen their spreads and shift their quotes to mitigate inventory risk. After the informed traders' burst of activity is over, the price reverts as market makers rebalance their positions. And this reversion is what the alpha captures. Okay. Finally, a truly superior alpha is not one trick pony. Must. All right. Let's get Grok in here. I don't. Hmm. Hmm. Uh. All right. Let's iterate and we'll just get Grok a quick answer here. And then we'll continue. All right. Come down way more. All right, your point. The script captures informed trading through the build time decayed OFI function, which quantifies persistent order flow imbalances. All right, so yes, informed traders create directional sustained order flow. Yes. So right now we need to take micro market structures, utilize that math, but actually forward project that. So do some sort of like, I guess, exponential moving average type stuff. Below I propose 3 novel trading techniques designed to extend. Okay, let's not. All right, now here's where we get to the good part. Okay. Mhm. So again, alpha score of 82, 85 on this one. Liquidity absorption rate. All right. Kind of getting worse and worse. All right, we'll let it think. It's not unclear. We were just going to iterate here. So these three have made it to the next stage here. So okay, we're gonna bring these to the report here. Um, okay. Yeah, we might as well try some AI indicators here. Um, actually, let's just focus on traditional and then we'll do an all AI indicator. Um, all right. How else can we? So we found out that um, my OFI EMA 1000, so an exponential moving average of the order flowing balance with a 1,000 millisecond half-life was actual alpha. This out of 1 million data points, 1 second snapshots, notably the data was amassed to. Okay. There was something there, which makes sense. This is exactly what we're trying to do. We're trying to take microstructure features and then bring that predictive power towards something that I can actually trade in real life. So very low negative O5 values associated with positive. Okay, we just have to reverse these things. Yeah. Okay. Thank you about information you've already provided. It's excellent and it's more than efficient. Okay. So this one, so you can't just drag it like that. We'll just have it take a look at that. We'll get the new enhanced alpha generator here. So we're going to we're going to save the alpha summary by just dragging it down here. And then we will just delete alpha summary. We're going to do alpha version 1, alpha v1. You know what? We're just going to do alpha 1. Okay. And we'll just keep iterating. We will keep looking for indicators so that once we find enough of the good indicators, then we can kind of tie them in together or just use each one singular. Like, we'll see how we're going to do this. But I think once we'll run this alpha report and then we'll run it on a full sample. You know what? Maybe we can just do that right now. We'll not do fast. Let's run it on a full set of the data just to see if that indicator actually made it through. So this is honestly probably going to take a minute, but it's actually worth running it through the whole data set before we move on to the new data set. Let's see what. Make sure we're not crashing the computer. Okay. Still working. Okay, we're gonna let this run for a little bit, and then we'll come back to see what the alpha report is in good detail. Yeah. Yeah, I really can't use my computer when it's just getting slammed like that. Just take a- Let's see what Google does. Okay, let's see what Google had to think of this. This is an excellent file, and the results from this stratified analysis are precisely why this type of regime-based testing is critical. The findings here are both powerful and importantly somewhat counterintuitive, which is often where the most robust alpha is found. Here's a breakdown of what the data reveals about your OFI EMA 1000 indicator. The signal is robust across all regimes. The first, the good news, the fundamental predictive nature of the signal that a strong negative OFI predicts a positive movement and vice versa holds true regardless of the market's liquidity. In every regime, the bottom decile has a positive return and the top decile has a negative return at the 10-second horizon. This is a strong confirmation that the signal is not just a statistical fluke, but a persistent feature of the market's microstructure. Finding two, the alpha is strongest in high liquidity. The key insight. Here is the most interesting and actionable finding. Here, let's look at the profitability of a simple long-short strategy based on this signal in each regime. Low liquidity, high liquidity, got it, 1 bit, okay. This shows that the signal is over 4 times more profitable in the most liquid market conditions compared to the least liquid. This might, oh wow, it finished. Oh, it didn't work. Well, either way, we got what we needed. Just gonna start making a list. So indicators. We're gonna just start making a list that um, of all the best ones. So this honestly is a little bit exciting because oh no, that's not what I wanted. No, I did want this. Okay. Now, could we just run this live? That's it? That's all we got here? Let's make sure. Hmm. I guess it only worked with fast, but it's all good. Yeah, OFI. Well, hold on. What was the best one? What was the top? Why did you give me this? Hold on. Hmm. So run this. Probably get some errors, but we'll run it back. Let's see what this guy's got to say about that data. So OFI in general is really good at predicting price. I think that's kind of what we're getting at here. Mm, okay. Yeah, so the OFI is like really reacting well to. All right, let's give it this data. Hmm. Okay. It's a very pronounced monatomic pattern. Very interesting. That's exactly what we want to see. Let's see how Grok reacts to its data. And we will let it think for a minute. We will get a list of, we'll do alpha 2. So this Very valuable stuff here. We're really making progress. Now we're able to quantify which indicator to focus on. Um, I already kind of knew that OFI was the way forward, but okay. Yeah. Okay. 40x. Okay. Yeah, if you're tuning in, we're finding real edge here. Oh no, he left. Okay. So let's see what Grok had to say. The alpha signals in the updated script represent a refined approach to capturing market microstructure dynamics with the removal of redundant features, streamlining the pipeline while integrating novel indicators, LAR, MDI, OBE. These enhancements build on the original foundation, emphasizing persistent edges in liquidity consumption, momentum reversion, and order book disorder. Below is a PhD level breakdown of why this alpha likely outperforms simpler strategies, grounded in the theoretical principles and empirical evidence from the output. The analysis highlights the retained core features and the new additions, focusing on their ability to quantify informed trading, latent demand, toxicity, and regime-dependent predictability. Informed trading via order flow balance. The script retains the OFI suite, OFI 1 second, OFI EMA 250, 1000, 5000, as a cornerstone for detecting directional persistence from informed traders who execute large orders that create temporary liquidity imbalances, aka they're taking out the order book, moving the price. Theory: informed trader and traders' activity generates sustained aggressive flow, exhausting liquidity on one side of the book. The EMA smoothing filters noise from this uninformed trades, isolating persistent signals. Multi-timescale EMAs adapt to varying information horizons, with shorter 250 capturing bursts and longer 5000 millisecond reflecting broader trends. Evidence: OFI EMA 1000 shows a negative relationship with forward returns, top decile versus bottom, indicating reversion after imbalance. This is consistent across timescales, with OFI EMA 5000 exhibiting even stronger long horizon reversion. This monatomic decile pattern affirms predictive power, outperforming raw OFI 1 second due to reduced noise. So an exponential moving average of OFI is pretty good. Now let's see here. Latent demand through book asymmetry, L1 imbalance and multi-imbalance. These features quantify supply and demand imbalances in the limit order book, where thicker bids as signals resistant to price changes and latent intentions. Theory: a thick bid reflects mechanical support, absorbing sells and informational confidence, attracting buyers. Multi-imbalance extend this to deeper levels, top 5, capturing broader liquidity distribution for robustness in volatile regimes. Evidence is right there. Shows monatomic predictability, top decile versus bottom decile, multi-imbalance mirrors this. Okay. Information flow and toxicity. VPN detects liquidity crisis near by measuring imbalance in volume, synchronized buckets, acting as volatility canary. Theory: Informed trading overwhelms absorption capacity in high VPIN periods, signaling impending volatility without directionality. It's non-directional, complementing OFI for risk management. Okay. So it's like incoming volatility. Evidence. Okay. Liquidity consumption via liquidity absorption rate. LAR quantifies the rate at which aggressive trades erode book depth normalized by average depth, signaling momentum or exhaustion. High undirectional absorption indicates informed aggression, depleting liquidity, predicting short-term momentum. All right, we got LAR. Okay. Theory: high unidirectional absorption indicates informed aggression, depleting liquidity, predicting short-term momentum if balance or reversion if exhausted. Normalization ensures robustness across depths, complementing OFI by focusing on speed and impact. Okay, reversion opportunities via momentum decay intensity. Informed momentum overshoots decaying exponentially due to mean reversion. MDI quantifies this rate. Volatility normalized for regime. It targets post-flow reversions, extending OFI's edge in overextended markets. In summary, this alpha outperforms by. This is Grok, Sasha. This is we're figuring out the edge here. Okay. This is definitely Grok. In summary, this alpha outperforms by integrating microstructure. Yeah. It's really good. We found some good stuff here. This alpha outperforms by integrating microstructure theory with novel signals. OFI for direction, VPIN for risk, LAR for consumption, and MDI post refinement for reversion. Okay, so now we'll take this and then help. All right, now we're going to take this data and we're going to back test it. Okay, here we go. Let's turn your find data into a full execution aware backtest strategy. All right. Okay, I'm going to do that. All right, I'm going to run this through Grok, ensuring that we can delete this. So these two scripts right here were really good. So, wait, are we recording? Oh, we are recording. We can pause that. Just stop recording. Okay. All right. Okay. All right, we're going to develop the full strategy here. And then we will update. We're not going to do look. Pre-processed data is probably going to have to. Why is raw so. Raw and pre-processed data will be deleted. Just kidding. Actually, we're gonna Keep that raw. I don't know what that does. No, I'm deleting that. Okay, now, new file. This is just going to be strategy one. Not py.txt. The algorithm is never complete, Sasha. It's constant research. No, I'm just joking. It'll be done. I'm gonna run this math through the backtest. So what we've done is we found the alpha, we found indicators that we want to move forward with that were giving us predictive power. And now now that we have that, we can quickly formulate the strategy. So it is essentially done now, but we'll just get the code implemented and then run a back test and then just to confirm. Oops. Yes, Sasha, very advanced. The math-driven strategy exploits microstructure innovation versus edge. Very fancy. Hopefully it makes me money, but we'll see. Let's see what Horizon Beta has to say here. Excellent. Let's turn your mathematical sketch into a complete backtest ready alpha specification with exact formulas. All right, we'll add this to. All right, smooth OFI. Okay, we got some EMA on the OFI. We got the book imbalance. We have the liquidity absorption. All right, B-pin toxicity, momentum decay intensity, and then OBE, standardized risk filters, directional. Okay. Okay, here's the decision engine. Trade, entry, exit, logic rules. Okay. All right. Now this is the easy part. All I got to do is say, hey, look at this code. Fully refactor it for, yeah, for my new strategy, strategy one. All right, we're gonna go, oops, bam, bam. I want to implement okay. We'll give it this. Double check that I ran that. We will, where is it? Raw. Okay, we'll run it with SuperGrok. We'll run it with this. We'll run it with O3. Run it with Cloud. Run it with Gemini. And yeah, run it. Hmm. Very cool. Very cool. Encoder only transform. Big genome research costs. Okay. So it's method to improve genome assembly accuracy. Encoder only. Yep, solid plan. Rock is still thinking. Okay. Okay. Six. All right, let's see. We're still working this. Um, we're gonna get Grok's answer into Gemini. Okay. So that config. It didn't finish. Winner by default suggests. Okay. Well, what did we run on this one? Whatever. Okay, big. Um, see if Gemini has anything to say about that. Big core. Okay, core is done. Pre-processed data, which we don't necessarily need. Honestly, that's pretty garbage. We will double check. Double check Grok's work there. So core and config. Backtest here. I don't know who to believe at this point. This. Agent reinforcement learning. Right. Backtest. That's still working. Backtest. Okay, so yeah, taker execution is good with slip. Okay. Let's get backtest in here. Yes. See who's a concise vertex strategy, consistent and data pumping. Their factor is better. Replaces legacy features. Okay. Let's just get a quick rundown here. Graph. Quick answer. Quick answer. Yeah, it's not helpful. See where Bitcoin's at. Yeah, we're chopping down here now. Yeah, new. All right, we're gonna use Grok's code. Um, oh, come on. You can do it. You can do it, Grok. Okay. Okay, we'll have Grok output the code here. Yeah, it's getting the new alpha here for our alpha's report. Let's just see how well we did with strategy 1. Hmm. Okay. That means we need to go to Grok. Okay. I believe this is where we kind of left off. Config. Config was fairly consistent for. Okay. Pre-process data. And then run. Run is changing completely, but okay. Okay. We'll run it back with Horizon since we kind of didn't. Okay. No, 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 no. Okay. We get alpha going here. That could be you. All right. Have we gotten some code out from these guys? We got core. Okay. We got config. Pre-process data. Sure. Okay. Mm, the full backtest file for we'll do run, and then we'll have like a run with like a fast command line or argument. Yeah. What happened there? Okay, produces audit CSV. Needed. Dude. Quick. Hello. Hello, hello. Welcome to the Alpha Report. We found some good edge here, guys. We found a bunch of good stuff. Alpha 1, Alpha 2 got converted into this. So we have a full strategy developed here, ready to test utilizing indicators that were predictive. They were predictive, it's OFI based. Yeah, we're predicting the market. Well, we'll see when we run it live, but okay. So keep getting code out here. Actually, not too sure. Okay. Yes. All right. We have um some people in the viewing area. We're just trying to figure out how to implement this strategy in code, essentially. We got order flow imbalance, EMA 1000, book imbalance, captures latent demand, VPIN, liquidity absorption rate, momentum decay intensity, order book entropy. Okay. Let's close out of that. Okay. Yeah, we don't want any of that robust. Okay. Mm. Okay, we'll just get this code outputted and then um, I'll run pre-process. Well, I'm running it now, but we'll run pre-process and then we'll call it a night and then just continue the alpha in the morning or after my job. Okay. Core. Got core here. Alpha refactor to align with nomadic strategy. Okay, cool off of those outages. Okay. I'm not sure what alpha has become now. Utils. Um, hmm. Alpha, I think, has become part of the overall code. It's no longer the alpha report. Unless it still is, I'm not too sure. But either way, we have the data right here to support what we needed. Okay. Let's get output to filters. Looking good. Ah, it ran out of. Oh, are we still here? We're still here. was this one? Huge. We're going to have to cancel that. Yep, okay. We're going to call it a night here. I'm going to stop the stream. Anyone have any rejections to that? No? Okay. Cool. We will continue this tomorrow. See y'all later.